Hello and welcome. My name is Kai, and in this tutorial I would like to share with you how we can access large language models like, for example, GPT-4o on SAP's Business Technology Platform. We will build a small and simple CAP application. CAP is the Cloud Application Programming Model. We will use the Node.js variant. We will use the SDK for AI Core to actually connect to AI Core. And within AI Core, we will use the Generative AI Hub, which allows us to access large language models on SAP BTP. And now, let's have fun with coding. Okay, then let's get started with part 1, where we will build the application from scratch and then use AI Core on SAP BTP to perform LLM requests. So first we want to make sure that we have installed globally the CAP development kit, so the CD SDK, which is in my case here already done. Now once we have that, we can initialize a new CAP project with CDS init and a name. The name will be CAP AI SDK. So that's now created, and we can cd into it. So there's a folder being created, and now we can start Visual Studio Code because we will do this here locally. Okay then, so we have a folder structure which was created by CDS init, and now we will open a new terminal, and first things first, do an npm install so that we have all dependencies installed which are in the package.json that has been generated by CDS init. After having done so, we want to install the SDK for accessing AI Core, which is the BTP component allowing us to call large language models. So this is done with npm install at SAP AI SDK /foundation models. This is one part of the AI Core SDK. So with that, we should have the major dependencies. And now we could already start our server, but this will actually not do anything because we have not defined any services. So let's change this, and I will bring in a prepared service definition file, which I called chatservice.cds, and it defines a chat service, requires an authenticated user because we want to later deploy it on BTP, and then of course users need to have an authentication. And then it defines one action which has the name question and also accepts a parameter named question being a string and returning a string. So this will basically map then to an HTTP post method on the CAP server, and we can already give this a quick try. So with CDS watch we can start our server, and now it's already running on localhost 4004. Looking quickly into that, so this is the default home page of this CAP server, and it defines endpoints also with metadata. There's a default user because we required an authenticated user. There's one predefined just for local development when you are using CDS Watch to start the server. The username is Alice and there's no password associated with it. And as you can see in the metadata file of this OData service, which is exposed now based on our service definition. So here we have an action with the name question and the parameter question, just as we have defined it in the CAP server. Now actually, if we want to call the action, we need to do an HTTP post, but obviously if we do so, nothing will happen because there is not any logic implemented so far, and we also have not associated this service here with any kind of a DB entity like you would normally do or could do using the Cloud Application Programming Model. But this is also not what we want to do in this quick tutorial. What we want to do here is call a large language model. So therefore we need to implement the logic. We will do this step by step, and first of all bring in an implementation file for our service definition. So it has the same name here, just a different file ending. By doing so, it will be loaded by default by CAP. You can give it a different name, but then you have to explicitly declare what the implementation file is. So for convenience and to have a clear file and folder structure, I like to use the approach of having the same name, so it will be easily recognizable what belongs together. In this chat service JS now we use default CAP way of declaring a custom service. So we are extending the class CDS application service with a new class chat service. We need to initialize it in the beginning by calling it super init. This is really important, otherwise it will not work, at least not very well. And now the major point here is we define an async method on our class which has the name question. This is the same name like our action in the service definition. By means of that, this method will be called whenever the post to this action is being executed. Now what we are doing here is just logging the question, and then this was not right. And then we are just returning a hard-coded response in the very first step, just to see everything's working well. We also log the response content, and then we return the response content, and this will return it actually to the HTTP post. So let's give it a try. First of all, save this file. Then, because we are in CDS watch mode, the service automatically restarted, so we can verify now that chat-service.js is being used as the implementation. So the file with the same file name has been successfully loaded. Okay, and because we need to do a post request, we need to use a tool which can conveniently help us doing so. In my case, I like to use Bruno very much because it's open source and free and you don't need any account. I have already prepared here a request in Bruno, which is a post request to HTTP localhost 4004, which is our server. And then you might remember from the index.html, there's a default prefix of any service, which is OData v4. And then we have chat. This chat actually comes from our chat service. So CAP automatically removes the word service in the end and just takes the first part of it and lowercases it, and this makes the endpoint for this service. And then within the service we have an action question. This is exactly like we expect because we have defined it like so. Then we need to have an authorization. So like in the browser before, I'm using Alice here, which can be used in CDS Watch only for local testing. Now we're going to execute our post. And what we can see here is that the response is being given. I'm a bot. I'm here to help you with your questions. And this was, as you might remember, the hard-coded value we are returning here. And from a previous test, I already have the body in my post request, which sends the question inside a JSON body. And the question is, who are you? And now looking here at the log, we can see question, who are you? So this was received over the post to question. This is our console.log, and here is our console.log for the response content. So far, so good, but now we want to use SAP AI Core to do a large language model request. On my BTP sub-account, I have already prepared an AI Core instance, into which also OpenAI GPT-4o is deployed. Now I want to make it usable here for local testing, because in this part of the video we are working local. So to do so, CAP offers a very convenient possibility. With CDS bind, we can bind our locally running application to a service instance on the BTP cloud, and CAP will handle in local execution the download of the credentials for the cloud service for us transparently and very conveniently. So when executing this CDS bind statement, a new file will appear. It's the CDSRC private JSON, and this will contain the definition of how to access the credentials. And this will be also used when we then execute CDS watch again with profile hybrid. But first of all, we have to implement some code. I have already copied in a module which imports the ESM module. This is what the SAP AI SDK is. So it's ESM, cannot be immediately required within our common JS-based CAP application, but we can import it dynamically. So, but here in this place, in this module, this is an MJS, so this uses the ESM interoperability of Node.js. And here we are importing it, and then we are defining an asynchronous function inside which a chat client is created for GPT-4o. This must of course be deployed on my AI Core instance like I have prepared it. And then when the function is executed, it will just run the LLM request, giving a system prompt and giving a user prompt. The user prompt being the question which is handed in as a parameter to this function. Now, where do we call this function? Clearly in chat service.js. So here we need to replace our hard-coded response with a call to that function, which is chatfunc. And where does chatfunc come from? Well, at the moment it is null, but we are using a dynamic import to load it from the AI Core.mjs module I just showed before. And then once it's loaded, it's assigned to this variable, and then it can be used here. This is probably not the most beautiful way to do it, but in our local prototype, this will work well because the chat service.js is anyways loaded when the server starts up. But of course, to do it more beautiful in a production environment, you may consider doing this a bit different. For our purpose now, important is that we start CDS watch again, but this time with profile hybrid, like shown here as an additional parameter. And this will do what I mentioned before. So it will now download the credentials from BTP and then inject them into our CAP server so that it can use these credentials. Coming back to Bruno, where we want to execute now our service again like we did before. It now takes a bit longer because now the LLM has been called and now the response is also different. It's not the hard-coded one we had before, and on each call it will look a little bit different because in fact GPT-4o is called here to formulate this response. So far so good for the first part, in which we implemented the application locally and showed how easy it is to integrate the AI Core SDK and make it usable to access a large language model on BTP. And this is now perfectly prepared to later on deploy the same solution into BTP on Cloud Foundry, for example, where it then can make an application binding towards the AI Core service, and this will handle all the credential flows implicitly via secure BTP mechanisms. This was the first part of our tutorial with the locally running application. Before we move on, I would like to point you to the description of this video, where I linked the GitHub repository, out of which you can download the code I'm using here, as well as all the command line prompts I have been using, so that if you want and if you have the prerequisites like a BTP account, you can follow along and try it out on yourself. And now let's move on to the next part, which will be the deployment. We want to deploy our application as a multi-target archive, and therefore we need to add this feature to our CAP application. We do this with CDS add MTA. So now the feature was added, and if you look at our file structure, so here we have a new file called mta.yaml, which actually is a declarative YAML file, which tells the system how to deploy the application to Cloud Foundry and basically to build the archive, which will then be uploaded. Another feature we want to add into our CAP application is an authentication. So we want to add XS-UAA authentication. So that's the Cloud Foundry model of how to secure applications, and we want to do it for the profile production. So this again also generated another file. We can leave this untouched for now. Of course, if you want to use it more sophisticated, you might have to do some settings in that file. For our simple example, we just continue. So having done so, we will now do an update, an npm update, with the purpose of fixing our package log file. This is required because, as you can see in the mta.yaml, there is an npm CI executed, and this relies on an up-to-date package log JSON file to install the Node.js dependencies. We also want to build our CAP application again for the profile production. And now, before we generate the MTA archive, the multi-target archive, we need to make some changes to the mta.yaml file. So one thing here is, if we look at it, there's a module declared. This is our actual CAP service. This can almost remain as is, but still we have some change here because we don't use any database, and I don't have a database, a HANA Cloud instance in my SAP account available. We need to remove this default and instead bind our application to AI Core. As I mentioned earlier, I have an AI Core instance already created, into which the Gen AI Hub is configured so that we can access large language models using AI Core. We also want to remove the database deployer as a dependency or as another application that would be generated and deployed, because again, we don't have any database. And we also want to remove the database container dependency, which would actually set up the connection to the HANA Cloud database if we had one. Now, one thing is still missing. Although we have declared a dependency to AI Core, we have not further specified what exactly this is, but we can do so by adding in another resource. Needs to go here on that level. And here we are saying AI Core. This actually references to the name AI Core, and we tell it what the service name is. Eventually, this is AI Core as well. So this is the service instance name I had manually pre-created, and that's an existing service. So therefore, the deployment does not want to create this service as it will do for the authentication, for example, because it's an existing one. There was an issue to fix in the mta.yaml file with the indentation of the service name. So I corrected this meanwhile. Service name is now indented correctly a level below parameters. And we try to build the archive again. And once the archive is built, I will also deploy it using cf deploy and providing the name of the archive that we just generated, like so. As you noticed, I have blurred out the console screen. It outputs a few data which I consider rather private and don't want to have in that video. And I will also just skip the entire deployment process. It takes 1 to 2 minutes. Deployment has now finished, and I have opened the BTP cockpit, the UI in which you can see what is going on in your SAP account and in your Cloud Foundry spaces. In my Cloud Foundry space, our application is now listed under Applications. If I click on it, I can see further details, and also under Service Bindings, I can see the service instances the application is bound to. That's now interesting in our case because we have 2 bindings like we expected. One to the existing service AI Core, which I added in like I showed before in the mta.yaml. And we have a binding to the XSUAA service instance, which was created based on the MTA YAML and also bound to the application. And by these bindings, implicitly, the authentication to these backend services is handled, and we don't have to deal with it any further. Heading over to Bruno, I have created a new request which uses the authentication type client credentials under OAuth 2. And here I have added in the URL parameter from the key.json and added the necessary suffix OAuth token in the end. This is the endpoint where to get the token, also the client ID from key.json and the client secret also from the file. Additionally, I added a script according to the documentation of Bruno, which will take the token we receive using this request, which is this one, and store it in a variable token. So we can come back to our previous test request, which does the post to our service. Here I made the server path a variable, which is defined in the Bruno environment. There's one for Cloud Foundry and one for local now. In Cloud Foundry, server path points to the endpoint of our application like we have seen it in the BTP cockpit. And under authentication, it's now switched to bearer token. And as a value for the token, it refers to the variable, which will be set by the other request. And now we can try to execute it, and we will get again a similar response like before, coming from the large language model from our application. And we can also try, of course, a different question. So let's use maybe this one. Briefly thank the viewers of my YouTube video, and let's see what GPT-4o says. And here we go. Thank you so much for watching my video. Your support means the world to me. If you enjoyed it, consider liking, subscribing and sharing with your friends. I appreciate each and every one of you. Thank you and goodbye.